All right, so today we begin our trek through Unit 6 with our first lesson on adding and subtracting rational expressions when we have a common denominator. So we're going to see over the next couple weeks that we're going to take this step by step, and each step is going to kind of add on a piece. So super important that each day you're getting the bare bones of what each lesson is going over, and see us if you have any questions. All right, so as you can see on the front page here of your notes, we've got this box talking about some key steps when we have that common denominator. So first and foremost, step one, we're going to add or subtract the numerators. Since the denominator is already the same, when we're adding fractions, if they're just numbers, we're allowed to add across the top if they have a common denominator. Same case here if it's a rational expression. Step two, we're going to place that sum or difference of the numerators that we found right over the common denominator. So again, we're going to put that together as one big fraction. And then step three is important moving forward as well. We're going to see this a couple times. We want to simplify the fraction if at all possible. Sometimes we'll find something that we can then factor and maybe cancel out with that common denominator, which would be great. So let's take a look at example one. And we're just looking not even at a real rational expression. This is just two regular fractions to recap and review from prior knowledge. So because we have a common denominator, we can simply add the 5 plus the 7. And we're going to put that all over that common denominator of 6. Or we can say that that's 12 over 6. And in this case, we can do step 3. We can simplify that and just say that it's 2. We don't want to leave the 12 over 6. So let's look at something a little bit bigger and better in example 2. So with example 2, again, we identify that the denominators are the same. So we're using this technique, and simply we are going to add across the top. So 6 plus x plus 2 all over one denominator, x minus 5. Then we can simplify the numerator at least and see what that's going to equal. X plus, in this case, we can combine the 6 and the 2 to make 8 over x minus 5. Now, in this case, this is a rational expression, and we would look to factor and cancel things in common, but x plus 8 over x minus 5 is already factored, and they are not alike, so we are going to leave that as our final answer. All right, example 3. So again, note here that we do have common denominators, so we can add straight across the top. However, there is a negative sign here, or a subtraction sign rather. So we do have to be super careful. What I'm going to do before we do anything is I'm actually going to change this to addition and change both of these signs. So that way I'm really treating this like an addition problem in the two previous. So the first numerator was x squared plus 3x minus 2. And now I'm adding on to that 4x plus 12. And that is all over x plus 5 times x minus 2, the common denominator of both fractions. Now we can clean up the top a little bit. That would be an x squared plus a 7x plus 10, still all over x plus 5, x minus 2. In this case, our numerator is a trinomial. So hopefully you were thinking about x games and the trinomial method. So we'll start by building the x. You should have a 10 on top and a 7 on the bottom. And we need two numbers that multiply to 10 but add to positive 7. You should be thinking about 5 and 2. So we'll go ahead and rewrite the numerator as x squared plus 5x plus 2x plus 10. And then we use that grouping technique that we learned to take the GCF out of each of the two sets that I underlined. So we'll take out an x from the first two terms. And they're both divisible by 2 in the second set, so we can take out a 2. And notice here that the x plus 5s are identical. So I'm going to come down to a rational expression we were working with, and I'm going to rewrite this numerator as x plus 5 times the GCFs that we pulled out, x plus 2. And it's still over x plus 5, sounds familiar, and x minus 2. So lucky for us, x plus 5s will cancel. And in this case, as tempting as it might be, we cannot cancel anything else because they are not identical factors. They're super close, but that plus minus is different. So we're going to leave this as our final answer. All right, last one, example 4. Let's get rid of this stuff over here so we have more space to write. So with example 4, in this case, we identify that there is a common denominator here. So again, they gave us subtraction. So I'm going to start by changing that to addition and send a negative through, distribute a -1 to each of those latter terms. And now I can combine into one big fraction. So this would be x squared minus 2x plus 3 plus negative x squared plus 4x plus 5 all over x squared plus 7x plus 12. Now across the top, we want to clean that up. So I notice here that there's an x squared term and a negative x squared term. They're going to cancel. However, the rest doesn't cancel out so nicely. We can combine like terms though. So negative 2x and positive 4x will give us 2x. And positive 3 and positive 5 will give us plus 8. Now the denominator, we didn't have to do this initially because they were like denominators, but now I do want to factor that because there's a potential here for something to cancel as we continue moving. So for the denominator, I'm going to come over here and build our x. We'll have 12 on the top, 7 on the bottom. Two numbers that multiply to 12 add to positive 7 should be 3 and 4. So rewriting the denominator, we have x squared plus 3x plus 4x from our x gains, and then plus 12 to wrap up. Again, we'll do that grouping technique. So we can take out an x here, and we can take out a 4 from this one. And notice that these are both x plus 3s. So when I rewrite the denominator, x plus 3. And our GCFs from our grouping technique provide the other one, x plus 4. Now we have to do one more thing before we can actually see if anything cancels, and that's deal with this numerator. 2x plus 8 has a GCF. So we can take out the 2. That'll leave us with, there it is, x plus 4, which does cancel with the x plus 4 that we found in the denominator. So we can cross those off. And our final answer here is simply 2 over x plus 3. So now that you've finished the notes for today, you can jump onto our weekly overview calendar and you can do the 5 practice problems turning in your work in Google Classroom. Let us know if you have any questions and good luck.